BGP Neighbour States. BGP uses TCP port 179 as its transport protocol. By using TCP, the peers are assured of a reliable connection. BGP maintains a table of all BGP peers and their operational status. The following list describes the various BGP neighbour states. Idle. This is the first state where BGP waits for a start event. The start event occurs when someone configures a new BGP neighbour. After the start event, BGP initiates a TCP connection to the remote BGP neighbour and will also start listening for a connection in case the remote BGP neighbour tries to establish a connection. Connect. BGP is waiting for the TCP three-way handshake to complete. When it is successful, it will send an open message and continue to the open state. In case it fails, the local system restarts the connect retry timer and continues to the active state. Active. BGP will try another TCP three-way handshake to establish a connection with the remote BGP neighbour. If it is successful, it will move to the open state. If the connect retry timer expires, then we move back to the connect state.
If you're enjoying the content, please consider subscribing, as 86% of viewers aren't currently subscribed.
BGP will also keep listening for incoming connections in case the remote BGP neighbour tries to establish a connection. Open sent. In this state, BGP will wait for an open message from the remote BGP neighbour. The open message will be checked for errors like having a wrong AS number coming from the peer, etc. And if an error is detected, then BGP will respond with a notification message and the system transitions back to the idle state. If no errors are detected, BGP sends a keep alive message. This is also the moment where BGP decides whether we use eBGP or iBGP since we check the AS number. Open confirm. BGP waits for a keep alive message from the remote BGP neighbour, and if we receive the keep alive, we can move to the established state and the neighbour adjacency will be completed. If we receive a notification message from the remote BGP neighbour, then we fall back to the idle state. BGP will keep trying to send keep alive messages. And finally, we have the established state. The BGP neighbour adjacency is completed and the BGP routers will send update packets to exchange routing information. Every time we receive a keep alive or update message, the whole timer will be reset. In case we receive a notification message, we will jump back to the idle state. BGP neighbour states. I don't actually intend to spend too long on this section, but we will reiterate what was mentioned in the graphic, and then we'll have a look at the devices that we've already configured for BGP. We're going to have a look at the 6 neighbour states. In the idle state, nothing's happening. The router isn't even trying to set up a BGP session. It's probably only being configured on one side or something like this. Then we have the connect, which is actually only very short. This is the one I don't think we're going to get to see, but in the connect state, the BGP starts a TCP three-way handshake, and then if all is good, then things are going to progress to open sent, and if not, then we're going to go into the active state. Also, the neighbor with the higher IP address is going to manage the connection. It's going to use like some kind of dynamic source port, 60,000 and something, and the destination port is always going to be 179. That's why we know that BGP uses TCP port 179. In the active state, BGP starts a new three-way TCP handshake. If it is successful, it's going to move to the open sent, and if it's not successful, then it will go back to the connect and try again. Open sent. This is when an open message has been sent and now we're just waiting for an open message to be received from the other side. Once this open message is received, then that message is going to be checked for errors like the BGP version, whether the AS numbers match what's being configured, whether the neighbor address matches what's being configured, etc. And if no errors are found, then it's going to send out a keep alive and move to the open confirm state. And if an error is found, it's going to send back a message and just sit there waiting in the idle state. Open confirm, then we're just waiting to keep alive from the neighbor, and then with the established, the BGP session has been established and we can start exchanging routes. So let's have a look at the 2 routers, customer A and customer B, that we just configured a minute ago. And we'll probably have to work backwards because this one's already working. Let's run show BGP neighbor. And we can see that we have the established state here. And the previous state was open confirm. And the open confirm is it was waiting for a keep alive from the neighbor, which it must have received. We could also see that the neighbor with the higher IP address has the random dynamic port number, and the one with the lower address has the port 179. So how are we going to change this a bit? We can try and maybe put in a wrong AS on one of these. Let's look at the BGP configuration. And we can see that the peer AS is being shown as 123. Let's just change that. Set peer AS as 12. We forgot the 3. Yep, let's commit that. And clear our BGP neighbors and see what happens. Okay. Right, now we can see 2 of the other states. We're in the actual, we're in the active state. And in the active state, it's like the BGP is trying to set up a new 3-way handshake, but it's unsuccessful. It bounced initially back to the connect state, more than likely, but because that state's so quick and nothing's happening, it's gone to the idle state, and yeah, nothing's happening. It's not even trying to set up a session because the peer address is incorrect. I wonder if it's the same on customer B. I would presume so. So let's look on customer B. Yeah, and we've got idle and active. Another thing that I'm going to do, I'm going to run a rollback 1 here. And I'm going to try and peer with a wrong address, maybe like the loopback address or something. See if anything changes. Maybe not. Clear. Maybe not even clear. Let's just wait and see if something happens. Okay. Well, it's actually saying it's established. Why is that? Open, confirm, and establish. Oh, because I've got both neighbors there. Let's delete. Okay, so let's now delete this neighbor. Delete neighbor 172.20.20.2. Confirm that. Run show BGP neighbor. Well, it's saying the last state is no state and the current state is idle. So we've transitioned into idle. And idle and active. Yeah, I don't think we're going to get to see open, send, and connect. Let's just wait to see if anything changes here. I will clear it, but I don't think we're going to see those. Run, clear. No. That's it for this video. We know that there's 6 neighbor states. We have to do some troubleshooting, and obviously we could go deeper with the troubleshooting by setting up some trace options and looking at the logs. This was just to show you how the neighbor states can change, and we'll move on to the next video.